Hello dear students, welcome to YourPedia. Today in this session I am going to discuss one of the very good model of GATE examination from control systems. So the question what I picked is from NPTEL assignments, okay, NPTEL assignments of control systems. So this question mainly from steady state error concept, okay. Let's enter into the question. The question is, for the system shown below, if there is 10% error in the steady state, so he's asking about steady state error, the error is mentioned in terms of percentage, 10%, then what is the normal value? 0.1. 0.1 is the normal value in the steady state. For unit ramp input, for which input it is going to give steady state error of 10% for unit ramp input, then the value of k is, he's asking the value of k. Very simple question, very simple but good question it is. This type of question you can expect in upcoming GATE examinations and other competitive examinations. Let's find it. Very easy it is. Yeah. So he's asking to find steady state error. He's asking us to find steady state error. That is, first of all, what is he given steady state error? He's asking us to find the value of k. Okay. Steady state error for ramp input is equal to A by kV. A by kV. But here we have to understand the value of A and kV carefully. What is A? A is slope of the ramp. Slope of the ramp input. Slope of the, yes, what? Ramp input. Slope of the ramp input. What is the input given by him? R of t is equal to unit ramp, t into u of t. Then what is the value of A we got? A is equals to 1. A is equals to 1. What is kV? Velocity error constant or ramp error constant or coefficient. kV is equal to limit s tends to 0 s into g of s into h of s. S into g of s into h of s. Now look at this ones. What is g of s into h of s given by him? Limit s tends to 0 s into, what is g of s into h of s? K into s plus 5 by s into s plus 6 into s plus 7 into s plus 8. S plus 7 into s plus 8. So from this what we get the kV value. So kV is equal to how much it is? 5k by 6 into 7 into 8. What is steady state error given by him? 10%. 10% means 0.1. So 0.1 is equal to A is 1 by kV is 5k by 6 into 7 into 8. 6 into 7 into 8. Let's solve it further. 10 is equal to, yes, or simply I can write 10 is equal to 5k by 6 into 7 into 8. Therefore k is equal to 2 into 6 into 7 into 8. Yes, I think it is 672. For this value of k, if you operate this particular open loop, this particular closed loop system, sorry, k is the open loop gain. This particular closed loop system, if you operate with a k value of 672, the steady state error what you are going to get is 0.1 or 10%. See, we all know that for particular inputs, particular systems are going to exhibit some non-zero steady state error. For some inputs, steady state error will be infinity. For some inputs, steady state error will be exactly 0. Let's see that also. That is very simple, That is very simple. I'll give you some small explanation. Okay, all of you, please concentrate on that. You can get very easily how to remember the steady state error concept. First of all, yeah, we have 3 standard inputs for finding steady state error. One is step input, another one is ramp input. After that, parabolic input. We never take impulse input. Yeah, this one question was asked in interview one time, that is why impulse input is not taken for finding steady state error. What is steady state error? Steady state error, yes, steady state error represented with ESS. Yeah, ESS is equal to limit s tends to limit s tends to 0 in S domain we are taking, or let's take our understandable domain, time domain. The name itself says steady state error. The value of error at steady state means t tends to infinity, means the value of the error when limit is tending towards infinity in time domain, or in S domain limit s tends to 0 s into E of s. Both the formulas will give the same answer. Okay, now if you take impulse signal, impulse is the signal which will exist only at t is equal to 0. Only at t is equal to 0. At any place other than t is equal to 0, the input itself is 0. First of all, there is no input at any place other than t is equal to 0. Therefore, at steady state, how much is the impulse input? 0. Input signal itself does not exist at other than t is equal to 0 for impulse. That's why we won't take impulse signal for finding steady state error. This is the answer for that question. Okay, that's a beautiful question. Only step, ramp and parabolic are used for finding steady state error. Standard signals these are. Okay, now let's remember that we have step input, ramp input, parabolic input. These are the three inputs we have. There is a relationship between input and type of the system. We know that. There is a very good relationship between input and type of a system. Type of a system is defined only for open loop transfer functions, and type of the system is the number of poles which are present at the origin of an open loop transfer function. Type is defined only from open loop transfer function. What is type? The number of poles which are present at the origin. Okay, so I am taking type 0. Let me go with the different color. Yes, I am taking type 0. Type 0. So I can say these two matches. Step 1 type 0 matches. There is some steady state error which is not equal to 0, comma, which is not equal to infinity. Neither 0 nor infinity. Some finite amount of error we are going to get. Same type 0, if I give to ramp, steady state error will be infinity. For ramp it is infinity, for parabolic also it is infinity. Means for a type 0 system, if you give step input, some finite amount of error you are going to get, neither 0 nor infinity, finite. But if you are giving ramp or parabolic, error will be infinity. Let's take type 1. If I am giving type 1 system to, if I am giving step input to type 1 system, error will be exactly 0. Means if you want 0 steady state error in your application, then this type of configuration you have to select. If your input is fixed as a ramp, if your input is fixed as a type 1 it is, if your input is fixed as a step, then you select type 1 system. Then that will give steady state error as 0. Now if it is ramp, steady state error will be neither 0 nor infinity, some finite value. If you are giving for type 1 system parabolic input, steady state error will be infinity. Yes. So if you want some finite steady state error, if it is accepted to have some finite steady state error with the ramp input for type 1 system, yes, you can get some finite steady state error for ramp input with type 1 system. Either of those two you fix, either input or type. Now I am fixing my type. My system is type 1. Then what input shall I give to achieve 0 steady state error? I have to give step input. If you are giving ramp input, you are going to get some finite value. Unknowingly or knowingly, if you are giving a parabolic input, you are going to get infinite steady state error. See, sir, I fix my input, then what type I have to select, that also we'll discuss. Means same analysis only. Now if I take type 2, system, yeah, for this one steady state error, with step input steady state error is 0, for ramp input steady state error is 0, for parabolic input some finite steady state error which is neither 0 nor infinity. Now let me take type 3 system. Okay, yes, type 3 system. Yeah, type 3 system. Steady state error for step input 0, for ramp input 0, for parabolic input is also 0. Okay, now fix the input. If my input is step, no type will use 0 steady state error. Type 0 also will use some finite amount of steady state error. Okay, type 0. Type 1 will use steady state error 0. Type 2 onwards, type 1 onwards steady state error is 0. If you are selecting step as input, except type 0, type 1, type 2, type 3, any type will use 0 as steady state error. 0 steady state error means if you want 0 steady state error with step input, you have to select any type of the system above 0 type 0, above type 0. If your input is ramp, you don't want any steady state error. First of all, avoid type 0 system. Why? Because it is going to give infinite amount of steady state error. Yes, infinite amount of steady state error. Yes, sir. Type 0 system for ramp input, infinite amount of steady state error. Avoid this type 0 system. Type 1 will use some finite. Type 2 is going to use 0 steady state error. Okay, if your input is ramp, you select type 2 onwards, type 2 and above, any type, steady state error will be 0. So this table is very important. If you know this table, any question from steady state error can be solved very easily. Okay, so please spend some good amount of time on this table, then you can understand it very easily. You have to remember it while applying to the problems carefully. Sometimes you may get confused. Thank you.